Hello. Now, we learnt in chemistry class at school that everything in the universe is built of the fundamental atomic building blocks that we know as the elements of the periodic table. This cookie, for instance, is made of milk and sugar. That means it's made of calcium, carbon, hydrogen and oxygen and a few other things. And we can easily determine that from a simple experiment that we could do in a lab. Now, if we want to know what a star is made of, which could be light years away, millions of light years away, how do we determine what the star is made of?
What seems impossible is made possible by a rather interesting phenomenon in which we use the properties of light. We realize that light from each object, be it the sun, stars, or a coffee mug, has its unique energy composition. A normal torch shines out energy in the form of light, which contains all colors: ultraviolet, red, green, blue, infrared. But our eyes are unable to resolve those colors. We just do not have sensitivity for most of them. What we can do, though, is to artificially split the light into its building blocks, energy units, or as we call it in everyday life, colors. And we do this using a special device known as diffraction grating. There are special repeating patterns in each stellar spectrum, dark absorption features, as you see behind me. These are called spectral lines. Using special quantum mechanical methods and laboratory experiments on atoms and molecules, we can identify which combinations of those patterns belong to which chemical element. This is the same principle as decoding DNA sequences. The light of its star contains such fingerprints and tells us what chemical elements make up that star. If you change magnesium or iron in the star, the spectrum would change accordingly.
There are 98 naturally occurring chemical elements that we find on Earth that we can see again in the periodic table. Using the elements in this table, we can combine any atoms together to create any substance that we find on Earth, for example, water. Now, to make water, we need hydrogen and oxygen. If we add in some silicon, we can make glass. And if we add in some carbon, plus some other things, then you can make a human being like me. Now, I myself am roughly 15 kilograms of carbon.
In a star, the proportion of chemical elements is totally different. A star is made of 25% of helium, 74% of hydrogen, and only 1% of all other chemical elements. So far, we have only been able to find out which elements make a star. To make one step further and to find out how much of a chemical element is there in a star, we need a computer calculation. And we do this by building a physical model of how the light goes from inside the star to the outside. And we call this a stellar atmosphere model.
By changing the physical properties of the model, for example, turning up or down the relative abundances of the chemical elements, we can find the model that best matches the observed data, and that's how we know what stars are made of. Only by studying the light from the star can we detect the signature of the planet's atmosphere next to the star. Even better than that, we can also detect the signature for water, an essential ingredient for life. It's cold!